Hey, what's up guys? This video is for section 0-2, which is real numbers. We are going to talk about what are the types of different real numbers in a number system. And we're also going to talk about a plan that we are going to use for the year when you guys are trying to solve or find the answer of a question. So let's start with that, with the plan that we are going to follow every time we want to find the answer of a specific problem. So on your screen, you guys can see 4 steps. And this is just 4 steps that I like to show my students that you can use. There's many ways you can solve a problem. There's many steps you guys can take. But this one here is just one example that you guys can use. And let's just look at the steps. When you guys want to solve a problem, you actually want to find the answer for that question or whatever problem is given to you. Step number 1, you guys need to understand the problem. It's not just reading what the problem is. You guys need to read it 2, maybe 3 times to understand what the problem is talking about, what you are looking for, and the type of information that you guys can use to find the answer. After you know what the problem is, you understand the problem, you guys go to step number 2. Step number 2, you are going to plan a solution, which means you start thinking. You're not going to start writing right away, but you guys start thinking, what can you do in order to find the answer? You are going to learn many different techniques in this class, Algebra 1, and you guys need to make sure what technique you can use to find the answer. So you're going to plan a solution. So you make sure you guys think about it, make sure you guys find a technique, and then you guys can go to step number 3. Step number 3, you're actually going to solve the problem. Now that you understand the problem and you actually know what to do, you have a plan, and that plan, guys, doesn't have to be perfect. It might not be right the first time, which is totally fine, but you guys need to actually do the problem. You need to solve the problem. And when you guys start solving the problem, use the plan that you guys thought about in order to find the answer. So you guys do the problem, you solve the problem, you do the work, and after you guys get a solution or you guys have an answer, make sure you guys check your solution, check the answer. This is step number 4. And one of the things that you guys can ask yourself is, does your answer make sense? Always try to make sense of the answer, make sense of the problem. You guys can say that 70-80% of the time when you guys trying to find the answer, it's just common sense. So don't make it too complicated for yourself. Just make sure you guys ask yourself, does my answer make sense? And then if it does, then you guys got the right answer. Now, once again, guys, remember that the plan that you guys thought about might not be perfect. It might not be right the first time. But that's totally fine. That's what we do in mathematics. When we find one answer or one technique, but it doesn't work, then we know we have to find another technique. We have to find another answer until we get the right one. And that's what you guys need to learn. If you don't get it right the first time, go ahead and do it second time, 2 times. And don't just try one time and give up. Make sure you guys try and persevere. Now the steps here is just, like I said, guys, something you guys can use, and I'm going to go back to the steps in my classroom so you guys know that we are trying to find the answers by using the steps. Now, after you know what plan to follow, you guys actually have some steps to follow. We need to know what techniques we can use. So the first thing we need to learn is the number system. Yes, you guys know what are numbers, but now you guys are going to go a little bit deeper and you will learn the names of the numbers. Yes, they do have names, and I'm not talking about 2, 3, the word 5, the word 10. Yeah, those are numbers, but they actually have a name, and there's different real numbers. So let's go to the next slide. So here you guys can see a table, kind of like a Venn diagram. It's not circles, it is squares, but it overlaps some squares, some rectangles, and you guys can see that every rectangle has a name. So let's talk about those names. So first of all, let's understand what is a number system. Number system is the system that has all the numbers that you can think about. Okay, you guys know zero, you guys heard about negative numbers, you guys heard about infinity, and there's many other numbers in between all those numbers. So the number system, it is composed of real numbers and imaginary numbers. All right, so first of all, let's just divide the numbers in two sections, two different types of numbers: real numbers and imaginary. What do I mean by real numbers? Real numbers are the numbers that you guys have been working with since elementary, since first grade, maybe kindergarten. You started counting different objects, so you guys learn about numbers. Those are real numbers. Why are they real? Well, those are numbers that we can use in real life. You guys can buy different items on the store, and you guys are using money. So money represents numbers. So it is a real number. Now, we also have what are called imaginary numbers. So now I'm looking at this section right here, imaginary numbers. Now, those imaginary numbers, we are not going to use them in Algebra 1, but you are going to look at those in Algebra 2, and if you guys take more mathematics classes, you guys will see those imaginary numbers again. Now, imaginary numbers is just what it says, imaginary. So those are numbers that we imagine what the number is if it is possible to find that number. So what do I mean? Let me just zoom in here. Okay, so you guys learn about square roots. You guys know what is the square root of 9, and we are going to talk about the square roots in the classroom. But you guys know the square root of 9 is 3. You guys know the square root of 25 is 5, right? Now, in order to find those square roots, you guys need to find the number that you multiply by itself 2 times that give you guys the number inside of the square root. So let me give you guys an example here. We know the square root of 64 is 8, because when you multiply 8 times 8, that's going to equal 64, which is the number inside of the square root. Well, guess what, guys? If you have a negative inside of the square root, just a negative inside like this one here, mathematically, it is not possible to find the answer. That's why we go to an imaginary. We imagine what the answer is. So imaginary numbers is just when you have a negative inside of the square root, just like this one here, you have a negative number inside of the square root, and the answer is going to be a number with an I. And it's just the square root of the number. So if you look at this one here, the square root of negative 9, well, that's going to be 3, because the square root of 9 is 3, but we do need an I, and I is for imaginary. Yeah, you guys got it. So we need the I to say this is an imaginary number. It comes from a square root that has a negative inside. That's what it means. Once again, we are not going to use those imaginary numbers in the class, but that's just an introduction of what they are. Now, what we need to focus on is real numbers. So let's look at that number system in the section where the real numbers are. So I'm going to zoom in right here, and under real numbers, there are 2 types of real numbers. So let's look at those right now. You guys have what are called rational numbers and irrational numbers. All right, now those represents real numbers, rational numbers and irrational. So before we actually go deeper into those numbers, let's go ahead and understand the definitions of rational and irrational. So let's look at the bottom right here, and I do have 2 bullets for rational. I know it's a little bit blurry right here, but this means rational numbers. So rational numbers are numbers that can be written as a quotient of integers. Now, quotients, let me just underline that word. Quotient means a fraction. So if you guys have a fraction with integers on the top and the bottom, and we'll talk about integers in a second, let me just tell you guys what they are. Integers are positive and negative numbers, but if you guys have a number that can be written as a fraction, then it is a rational number. Also, a rational number are numbers that can be written as decimals. So you guys know that are decimals, but this is very important. Decimals that terminate, which means it stops somewhere and it can stop 3 numbers after the decimal, 10 numbers after the decimal, or 20 numbers after the decimal, but it stops somewhere. So that's terminate. Or the decimal is repeating. And you guys seen the repeating sign before when you guys have a decimal 0.33333333. Well, you guys don't have to write down all the 3's after the decimal. So we just put a 0.3 with the little bar on the top, which means it's repeating. So that is a rational number. Fractions, numbers that you can write as a fraction, and numbers that can be written as a decimal that terminates or repeats. Okay, so that's rational. Irrational is just the opposite. So let's look at irrational numbers. So irrational numbers are numbers that cannot be written as a quotient of integers, so no fraction, and some numbers you cannot write those as a fraction. Yes, we do have some numbers that you cannot do that. So those are irrational. And or numbers that cannot be written as a decimal that terminates or repeats. So some decimals do not stop. They keep going and going and going and going to infinity. They actually just keep going and going. They never stop, and they never repeat. Now, when I say repeat, you see that I'm talking about a pattern. There's no pattern, something repeating over and over again. Okay? So those are irrational. Now, let me show you some examples for rational and irrational number. So let's look at the rational numbers first. Okay? Rational numbers, you guys see some rectangles right here. Let me just zoom in a little bit more. So let me just go all the way to the center right here. Let's start with these numbers here. Okay? You guys see the numbers 1, 2, 3, 4, and it has a dot, dot, dot. That means that the numbers just keeps going and going and going. So after the 4, you have a 5, and then a 6, 7, 8, 9, 10, 11, 12, and it keeps going to infinity. So notice that the numbers start from 1 and it goes all the way to the positive numbers infinity. Those are called natural numbers, and they are whole numbers, but you guys will see whole numbers on the second rectangle. But natural numbers are not decimals, they're not fractions, right? And their positive numbers starts at 1. When you guys go on to the next rectangle right here, now we have whole numbers. Now your whole numbers, you guys already know what they are. But a whole number is including the 0, and it keeps going to positive infinity. So the 1, the 2, the 3, the 4, the 5, the 6, the 7, and it keeps going, but it starts at 0. That is a whole number. Now you notice that the natural number, the rectangle, is inside of the whole number because natural numbers are also whole numbers. But if you guys say just natural numbers, well, you cannot say that 0 is a natural number because 0 is not in here. 0 is with the whole number rectangle. So you do have natural numbers inside of the whole numbers, but 0 is just a whole number. If we guys expand further out, now you guys have a bigger rectangle. And the next one are integers. Okay, now integers, these are including the whole numbers and the natural numbers. So notice here we have the 0, which is a whole number, and then we have the numbers on the positive side, the 1, 2, 3, 4, and it keeps going 5, 6, 7, 8, all the way to infinity. So integers are including the whole numbers and the natural numbers, but they are also including the negative numbers. So on the left side of the 0, we have the -1, the -2, the -3, and it keeps going, -4, -5, -6, -7, -8, all the way to negative infinity. So those are integers. Now, look at the numbers very carefully. Integers are not decimals, they're not fractions. Whole numbers, obviously, not fractions, not decimals. Natural numbers, not fractions, not decimals. But integers, we do have the whole numbers in those integers, and we also have the natural numbers in those integers. All right. Now, if you guys expand even further, right up here, guys, you guys see some fractions, some decimals, fractions with the decimals. All of these right here, guys, they do represent rational numbers. Now, rational numbers are just numbers, remember the definition down here, that can be written as a fraction or as a decimal that terminates or repeats. Now, you guys have to understand though, integers are also called rational numbers. Notice the rectangle for integers is inside of the rational numbers. Whole numbers are also called rational numbers, and natural numbers are also called rational numbers. Now, you might be thinking, well, rational numbers are fractions or decimals. How can you guys say that an integer is a rational number? Well, if you think about it, any whole number, you can turn it into a fraction. How do you do that? Well, if you guys look at the 4 here, in order to turn that 4 into a fraction, you just put a 4 over a 1. You just put a 1 under the number, and that's the same thing as 4. So we turn that into a fraction. Now, once you guys turn that into a fraction, it's not a whole number anymore. It's not an integer anymore. It's an actual rational number. You guys can do the same thing with the negatives. If you guys take the -3 right here, -3, and you put that over 1, and you guys have a fraction. So every integer, every whole number, every natural number is also called a rational number. But I want you guys to look at those fractions up here and the decimals. Notice, this fraction has a negative. Not an integer because it is a fraction. Integers are not fractions, but it is a negative fraction. So this one's a -1/2, which is a rational number. Now, why is it rational? Because this one here, you can also make it as a decimal. -1/2 is the same thing as -0.5. So -0.5, it stops at 5. There's no more numbers after the 5. So that's a rational number. 3 over 4 is a fraction. Same thing as 0.75. Notice it stops here, 75, boom, it stops at 5. So that's a rational number. This one here is a fraction, 23 over 1,000, or 0.023. You convert that into a decimal, and it stops 0.023, boom, it stops right here. So that's a rational. 25 over 99, well, that is also a rational number here, because this one is a fraction, and this one here, 0.25, 25, 25, well, guess what? That has a pattern. Some numbers are repeating, 0.25, 0.25, 0.25, 25, 25. It's the same thing as 0.25 with a little bar on the bottom. The 2, 5 are repeating, so you guys put the bar on the bottom. I'll give you guys another example, okay? 1/3 is a rational number because 1/3 is 0.3333, and it keeps going and going and going, but you guys can write it as 0.3 with the little bar on the top. So these are rational numbers. Rational numbers, decimals that terminate or repeat, numbers that can be written as a fraction, and you also have whole numbers, integers, and natural numbers. Now, let's look at irrational numbers. Now, notice irrational, it has like a wall in between here. It's dividing, it's separating, right here, guys. It's separating the rational numbers and irrational. So these are irrational. Now, why are they irrational? Remember, irrational numbers are numbers that cannot be written as a quotient, which means a fraction. Nope, you cannot do that, of integers, and you cannot have a decimal that terminates or repeats. Well, let's look at those examples that I have here. You guys can see the sign for pi. Pi is irrational because the decimal for pi is, and you probably already know it, 3.14159, and it actually keeps going and going and going and going and going to infinity. So that value, the value of pi, you guys know the sign in geometry, you guys seen this before, it doesn't stop. So it is irrational. The numbers, there's no pattern, the numbers are not repeating, and the decimal doesn't stop. Another example is the square root of 2. The square root of 2, you guys can have, when you turn that into a decimal, 1.414123, and it keeps going and going. Now, I have a very common question from my students, and the question is, well, what about the 4141? Those numbers are repeating. Well, you're right, but they only repeat 2 times. It doesn't repeat over and over and over and over, just like this one up here, or this one up here. Doesn't repeat again and again and again and again and again. So we say that this one here is not repeating. Even though you guys see those only 2 times after the 3 here, you don't see those numbers again, the 4, 1, 4, 1, 4, 1. So it is irrational because it's not repeating and the decimal doesn't stop. It keeps going and going and going. Now if you try it in a calculator, well, a calculator can only give you guys so many numbers, guys. It's not going to give you 1,000 numbers after the decimal. It doesn't have enough space. So they only give you guys sometimes 10 different numbers after the decimal, sometimes 12. It depends on the calculator, sometimes 9. But it only give you guys up to a specific number of decimals, but it keeps going and going and going. So this one is also irrational. Now E, you guys haven't seen before, but once you guys go to Algebra 2, you guys will see it. E stands for the Euler's number. That's just the name of a mathematician back in the days. But he came up with this value. E, think about like pi. You guys know pi is 3.14159. Some people say it's just 3.14, but it actually keeps going. Well, E, same thing, it has a value. And the value of E is 2.718281, and it keeps going and going and going. Well, this one, guys, is irrational because the decimal keeps going and going, and it never stops. And the numbers are not repeating. There's no pattern. So it is irrational. All right, so let's go ahead and practice. Here I have a list of numbers that I want to practice with you guys, and I want to name the set of numbers to which each real number belongs. Now, you guys can use different names for those numbers. Remember, a whole number is also a rational number. A natural number is also a rational number. Integer is also a rational number. So there's a couple, maybe 3 different numbers that you guys can use. So let's go ahead and look at those numbers there, okay? So the first number I want to show you is the fraction, 8/3. 8/3, obviously we know that's not a whole number. It is a fraction. So the name of this fraction, and when you guys have a fraction or a decimal that terminates or repeats, is called rational number. So let me just put the rational word right here. So it is a rational number. That fraction belongs to that rectangle, the rational. Let's look at the bottom number, the square root of 81. Now, think about it, guys. Make sense of the problem, just like the plan I gave you guys at the beginning of the video. You guys need to understand the problem, make sense of the problem, and you guys try that. You guys actually find the answer. Square root of 81. Makes sense. What is the square root of 81? Well, the square root of 81 is 9. All right? Now I want you guys to look at this number, 9, not the square root. Look at the value 9, the actual number 9. The square root of 81 is 9. Well, that's a whole number. Okay? So let me just put here, whole number. Guess what? It's also an integer, because it is a positive number, integer. So positive 9 is an integer, it's a whole number, and since it is a positive number and it's a whole number, it's also a natural number. So look at the number, the names that we are using for that specific number. The number 9 is a whole number, integer, natural number, and every number you can also say it's a rational number. So let me put here rational number. So we know 4 different names for that number. Now, when I ask you guys for a specific name, you guys can give me one, but I want you guys to practice, and I want you guys to write for this section. I want you guys to write all the names. Now, the next one, the square root of 2. Square root of 2 doesn't have a perfect square root. Like square root of 81, we know that's 9. The square root of 16, we know that's 4. Square root of 2 doesn't have a perfect square root. But if you guys use a calculator, you guys will get a decimal. Now, guess what, guys? That decimal is not going to terminate. It's not going to stop. And actually, I gave you guys the example for the square root of 2. But the value, let me just write down the value, the actual decimal. And like I said, guys, this is an approximation. So let me just use this little squiggly thing. which means approximate 1.41421, and it keeps going and going and going. Since it keeps going and going and going, and there is no repeating numbers, there's no pattern, you guys will say this is irrational. So that's an irrational number. We don't have another name because an irrational number is just an irrational number. Now let's look at the next one here. Okay, and the next one is the square root of 28. The square root of 28 doesn't have a perfect square root answer. What I mean is, square root of 28 is going to be a decimal if you use a calculator. How do you know, guys? Well, think about it. Make sense of the problem. I know the square root of 25, that's 5. The square root of 36, that's 6. But the square root of 28 is not a perfect square root. So this is going to be irrational, because when you turn into a decimal, it's not going to terminate and it's not going to repeat. So this one is irrational, and that's just a trick that you guys can use if you want to know if it's a rational number or irrational. If the number inside of the radical, this number, the 28, doesn't have a perfect square root answer, then you guys can say it's irrational. Okay, let's look at the next one. Number 17. Well, guess what? That is a positive 17. How do we know it's positive? Because on the left side of 17, there's no minus. It's just a positive sign, and it is positive, invisible, because we don't need to put the plus next to the 17. Every time you guys have a positive number, you don't need to put the plus on the left side. If it's negative, you guys do need the negative on the left side, but right now it's positive. So it is a positive, so right away I know that's a natural number. Positive numbers are natural numbers. Guess what, guys? It's also a whole number, so we know this is a whole number. It is an integer because it is a positive number, integer, and we can also say it's a rational number. So we have 4 different names for this specific number, 17. They're all the names: natural, whole number, integer, and rational. Now this one here is a little bit tricky, the next 2 square roots, because you guys see a negative outside of the square root. So let me explain what that is. Okay, we talk about imaginary numbers, we talk about real numbers. When you guys have a square root and there's a negative inside, when I say inside, I mean right here in between the square root of the number, inside of that square root, then it is going to be an imaginary number. But if the negative is outside with the square root, it's not imaginary, it's going to be a real number. Now, what type of real number is it? Remember, we have different names for real numbers. Well, first of all, let's make sense of the problem. We know that 21, the square root of 21, is not a perfect square root because 21 doesn't have a perfect square root answer. You guys can say the square root of 16, which is kind of close to 21, is 4. 25, the square root of 25 is 5. But 21, the number 21, doesn't have a perfect square root number. So even though it's negative right here, okay, even though it's negative, the negative is outside of the square root, but this number doesn't have a perfect square root number, then we can say it's irrational because 21 doesn't have that perfect square root answer. Now the next one. The next one, it is a negative outside of the square root, but 121 has a perfect square root answer. The square root of 121 is 11. But since we do have a negative outside of the square root, we must keep that negative and we put the answer. So the negative square root of 121 is negative 11. Now you guys can start looking for those names for this negative 11. First of all, not natural because it's not positive. Natural numbers are only positive numbers. But this one, it is an integer. Integer. We don't say whole number because whole numbers are only the 0 and the positive numbers. So it's not a whole number, even though it's not a fraction, but it has a negative. So it's not a whole number, it's not a natural number, because those are only including the positive numbers, and whole numbers including the 0 and the positive numbers. But this is negative 11. It is an integer, and we can also say rational number. So we have two names, integer and rational. Now the next one here, we have decimals, okay? 0.3 with the bar on the top. Well, this, I kind of already give you guys this example, but 0.3 with the little bar on the top, it equals 0.3333, and it keeps going and going and going and going. It is a decimal. It is repeating. It doesn't terminate, but it is repeating. So we say this is rational. It is a rational number because it is repeating the numbers, rational. If they're not repeating or it doesn't terminate, then we say it's irrational. But right now it's rational. The next one, okay? Next one, 0.675. But guess what, guys? You have a decimal, 675, and it stops. So this decimal stops at 5. It doesn't keep going and going and going. It doesn't have the little dots after the 5. So they tell you that it stops. So a decimal that stops, which means terminates, it's rational. Okay, and the next one is just pi. So you guys have the sign pi here, and you guys know that pi is approximately 3.14159, and it keeps going and going and going. Doesn't repeat, doesn't terminate. So we say pi is irrational. So it is irrational number. So we have rational, we have irrationals, whole numbers, integers, natural numbers. And the last number here is -5. Notice it is a negative number. So first of all, it is an integer. It is not a whole number because whole numbers, remember, those are only positive numbers including the 0. So this is an integer. It's not a natural number because it's negative. But we can also say this is a rational number. Now, why is it a rational number? Because you guys can turn that -5 into a fraction. If you just put a fraction line and a 1 under the number, it's a fraction, -5 over 1. So it is a rational, but it's also an integer. Alright guys, so this concludes the first video for this section. I'm going to have to do a second part for section 0-2. So make sure you guys check that out and make sure you guys practice, and I'll see you guys later.